Hello friends, welcome to HP Environment Academy. In the last lecture we have discussed up to question number 28. So I will discuss question number 29 onwards in this particular lecture. Basically we are discussing the problems on the vector identities. Okay, so let's start our discussion. So what we have seen in the previous set of lecture is that for solving such type of questions, they are set of identities, they are set of results that are required for solving the problems on the vector identities. So let's start our discussion. Okay, so let us go through those vector identities that are required for solving such type of questions. Okay. Okay, so the first vector identity is, let us consider phi as a scalar, phi as a scalar, okay, and a as a vector quantity, vector. So the first one is, we have the divergence of phi a, where a is the scalar quantity and a is the vector quantity. This is equal to del phi dot a plus phi times of del dot a. Okay. Second result is curl of phi of a. Curl of phi of a is equal to del phi cross a plus phi times of del cross a. Okay. Third one is gradient of function of r. Okay. Suppose f is a function of r. This is equal to f dash r. Differentiation of f with respect to r. Gradient of r, that is del of r. Del of r is r vector upon r. Del of r is r vector upon r. Let us place this. So this is f dash r vector upon. Okay. Fourth one is curl of gradient of phi. Curl of gradient of phi is 0. Fifth one, we have the divergence of r vector is equal to 3. Sixth one is curl of r vector equal to 0. Curl of constant vector is also 0. So we have seventh one as curl of constant vector. Suppose a is a constant vector, then curl of a is, okay. Now we have the eighth one as divergence of a cross b. A and b are vectors. Divergence of a cross b is b dot curl of a, dot product of b and curl of a minus a dot curl of b. Okay. Now we have ninth one as, let us take three vectors a, b and c. The cross product a cross b cross c, this is equal to a dot c into b minus a dot b into. Okay, so these all vector identities are required for solving such type of questions. Okay, so let us start discussing the problems. Okay, so the first one is, that is question number 29 is, u is equal to 1 upon r vector, then find gradient of divergence of u. Okay, so let's start. Okay, so the first question is, that is question number 29. This is u is equal to 1 upon r of r vector, then find gradient of divergence of u. This we have to find. So let us solve this. We have we have the value of u. So u is equal to 1 upon r of r vector. Okay, so let us compare this with this one. We have to find the divergence of u. So let us use first result, this one. Okay, so we have the divergence of u as, divergence of u is equal to divergence of 1 upon r vector. Let us take phi, because phi is a scalar. Let us take phi is equal to 1 upon r and a is equal to r vector. So 1 upon r is phi and r vector is, okay, so this is equal to, let us expand this using this formula. Okay. Gradient of 1 upon r dot r vector plus 1 upon r of del dot r. Okay, so gradient of 1 upon r, this is minus 1 by r square, r vector upon r dot r vector. plus 3 upon r. So this is equal to minus 1 by r square into r square upon r plus 3 upon r. This gets cancelled. This is equal to 3 upon, sorry, this is 2 upon r. Let us write down one step further. So this is minus 1 by r plus 3 upon r. This is equal to 2 upon r. Okay, so the divergence of u equal to 2 upon r. So let us find gradient of divergence of u. So we have the gradient of divergence of u. This is equal to gradient of 2 upon r. Let us use this formula. Gradient of f of r is equal to f dash r into del of r. F dash r. So let us take 2 upon r as f of r. Okay, so the f dash r will be minus 2 upon r square. This is equal to f dash r. Just take 2 upon r. So gradient of f of r. This is equal to f dash r into del of r, and del of r, and del of r is r vector upon r. This is equal to f dash r into r vector upon r. F dash r is this minus 2 upon r square. Minus 2 upon r square into r vector upon r equal to minus 2 upon r cube into r vector. This is the result. So the gradient of divergence of u is given by minus 2 upon r cube r vector. Okay. Now let us discuss question number 30. Let us discuss question number 30. Question number 30 we have, if del square f of r is equal to 0. If del square f of r is equal to 0, then we have to show that f of r is equal to c1 log r plus c2. Okay. We have r square is given as x square plus y square. Okay, so let us solve this. So from here we can derive one result. Okay, so let us differentiate this with respect to x. R del r upon del x equal to 2x. So from here del r upon del x is equal to x upon r. Similarly, del r upon del y is equal to y upon r. So we have del square f of r. This we can write as del square upon del x square plus del square upon del y square of f of r. Okay, so let us find del square upon del x square of f of r. This is equal to del upon del x of del upon del x f of r. Okay, so this we can further write as del upon del x of del upon del r. We can differentiate f of r with respect to r of f of r into del r upon del x. Del r upon del x is x upon r. This is equal to del upon del x of f dash r to x upon. Okay, so let us further simplify this. So we have del square upon del x square f of r equal to del upon, let us differentiate, this is del upon del x of f dash r upon r times of x. Okay, this is first function and this is second function. Let us differentiate this. This is equal to f dash r upon r and the differentiation of second function. Differentiation del upon del x of x is 1 plus x times of del upon del x of f dash r upon r. This we can further simplify this, f dash r upon r plus x times of, this we can differentiate because this is a function of r. We have to differentiate this with respect to r first. F dash r upon r to del r upon del x. Okay, and del r upon del x is x upon r. F dash r upon r plus x upon r. Del r upon del x is x upon r. This is x. So this is x square upon r. This is differentiation of f dash r upon r. This is r square r times of f double dash r minus dash r. Okay, so let us further simplify this. This is equal to f dash r upon r. From here we have, this is r gets cancelled, x square upon r square plus x square upon r square f double dash r minus x square upon r cube minus x square upon r cube f dash r. Okay. Del square upon del x square f of r. Now let us write down here. So we have del square upon del x square of f of r. This is equal to f dash r upon r minus x square upon r cube f dash r plus x square upon r square f double dash r. Okay. Similarly, del square upon del y of f of r is equal to f dash r upon r minus y square upon r cube f dash r plus y square upon r square f double dash r. Okay. Now let us add this. So from here we have from equation 1, this is equation 1, this is equation 2 and this is equation 3. So from equation, let us put these values in equation 1. So we have del square f of r equal to, let us add this is 2 times of f dash r upon r. From here this is, so once we add this, so in the numerator we have minus x square plus y square upon r cube. This is f dash r plus x square plus y square x square plus y square upon r square and this is f double dash. Okay. This is equal to 2 times of f dash r upon r minus this is r square. So r square upon r cube times of f dash r plus x square plus y square is r square. So this is 1 f double dash r. And this is r square upon r cube. This will be 1 upon r. 1 upon r. So from here this is 2 upon r, this is 1 upon r. So this is equal to 1 upon r f dash r plus f double dash r. This is equal to 0 because given that f dash r del square f of r is 0. So this is equal to 0. So from here we have f double dash r is equal to minus 1 upon r f dash r. From here f double dash r upon f dash r is equal to minus 1 upon r. Let us integrate this with respect to r. We have f double dash r upon f dash r dr is equal to minus 1 by r dr. Let's integrate this. This is log of f dash r equal to minus log of r plus log of c. So from here we have log of f dash r equal to log of c upon r. F dash r is equal to c upon r. Let us integrate this further. So we have f dash r dr is equal to c upon r dr. Let us integrate this. This is f of r is equal to c log r plus, let us take this as c as c1. So this is equal to c1 log r plus the result that we have to show. Let us discuss question number 31. How we can solve this? So we have question number 31 as half of del a square is equal to a dot del into a plus a cross curl of a. Let us solve this. So we have half of del a square. This we can write as, and del we can write as summation of I del upon del x equal to half of summation I del upon del x of a square we can write as a dot a equal to half of summation I 8 dot del a upon del x plus del a upon del x dot a. This we can write as 2 times. This is half of 2 times of summation I a dot del a upon del x. This is equal to summation a dot del a upon del x of I. This is half of del a square. Okay. So let us use this identity A cross B cross C. We have A cross B cross C equal to A dot C minus A dot B into. So from here we have A dot B into C equal to A dot C into B minus of A cross B cross C. Okay. Let us take. Let us use this identity with respect to this expression. We have, let us take A as it is, and let us take B as del A upon del X, C as I. Okay, so from here we have A dot del A upon del X times of I equal to A dot C we have taken as I. A dot I times of B is del A upon del X minus A cross B is del A upon del X. C is I. This we can further simplify as I times of del A upon del X. We can write this A dot I del A upon del times of A. We have taken summation here, so let us apply summation. This summation minus summation. We can reverse this. Reverse the order. This is del A upon del X. We can write as I cross del A upon del X. This will be plus. So this A cross I cross del A upon del. Okay. So this is equal to summation. This A time A dot summation I del A upon del X times of A plus this is nothing but curl of A cross. This we can write as summation. We can take in I cross del A upon del X. Let us further simplify this. We have the value as this value is equal to, this is A dot summation I del upon del X of A plus A cross summation I cross del A upon del. This expression is nothing but curl of A. This expression summation I del A upon del X is del equal to A dot del into A plus A cross curl of A. This is nothing but half of del A square. Now let us solve question number 32. Let us solve question number 32. Okay, so we have to show that curl of phi of r in A vector equal to half of phi dash r vector cross A. Let us use this expression curl of phi A, where phi is scalar and A is vector. So let us use this. We have curl of del cross phi A vector. Let us use this expansion. This is phi of del phi. This is del phi cross A plus phi times of del cross A. Okay, where A is constant vector. A is constant. Del cross A, that is A is constant. So del cross A, del cross constant vector is 0. This is straight away 0. We have del of phi. Phi is a function of r. So this will be equal to phi dash r into del of r cross A r है ना, upon r 1 upon r. This is equal to phi dash r. Del of r is gradient of r is r vector upon r cross A. So this we have to show in the question. Let us discuss question number 33. Let us discuss question number 33. So we have proved that del square phi of psi equal to phi of del square psi plus times of del phi dot del psi plus phi times of psi times of del square. Okay, कैसे करोगे इसको? Let us solve this. So we have del square phi of psi, both are scalar. This is equal to this, we can write as divergence of phi of, sorry, divergence of del of phi into this, we can write as divergence of phi times of gradient of psi plus psi times of gradient of. We have this as del dot phi of del psi. Del psi is a vector quantity. Gradient of scalar is vector quantity. This we have already studied. Plus divergence of psi into del phi. This we have already studied. Okay, so let us apply this expression where phi is scalar quantity and A is vector quantity. Del of psi is vector. Del of phi is vector. Psi is scalar. Phi is scalar. Let us apply this. This is equal to del phi dot. Let us expand this using this expression. So we have del phi dot del of psi plus phi times of del dot del of psi. This is the expansion of this one. Now let us expand this. This is plus. This is del psi dot del of phi plus psi times of del dot del of phi. Okay. This is equal to this one and this one is same. This is phi times of del square plus 2 times of del psi del phi dot del psi plus psi times of del square equal to del square phi of the solution of this particular question. That is question number 33. Now let us discuss question number 34. Let us discuss question number 34. So we have proved that divergence of del phi cross del psi equal to 0. So let us use this particular identity. We have divergence of A cross B, but let us take A as del of phi, del of B as del of psi. We have divergence of A cross B equal to B dot curl of A minus A dot curl of B. Divergence of del phi cross del psi equal to B times, so B is del psi dot curl of A is del phi minus A is del phi dot curl of del psi. Curl of gradient of phi is 0. Curl of gradient of psi is 0. In this particular identity, this is del of psi into 0, del of phi into equal to. Now let us discuss question number 35. A and B are irrotational. Prove that A cross B is solenoidal. कैसे करोगे इसको? Question number 35. Question number A and B are irrotational. Given that A and B are irrotational, so we have to show that cross B solenoidal. Okay, a vector is said to be solenoidal if divergence of that vector is 0. So by this we mean divergence of A cross B equal to this, we have to. Okay, so this is similar to this particular statement. A cross B is solenoidal means divergence of A cross B is 0. Let us find divergence of A cross B. Divergence of A cross B is P dot curl of A. P dot curl of A minus A dot curl of B. Given that A and B are irrotational. A is irrotational means Curl of A is 0. B is irrotational. Means curl of B is 0. Curl of A is 0. This is 0. Curl of B is 0. This is. This divergence of A cross B is equal to B times of 0 minus A times of 0. This means divergence of A cross B 0. This means A cross B is solenoidal. Okay, so we have discussed up to question number 35. So we will discuss further questions in next particular lecture. Thank you.